Okay, so today we're going to begin Chapter 8, Section 3, and we're going to learn the last two shortcuts for showing that two triangles are similar. The first shortcut is side, 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 and the second one is side, angle, side. So let's go ahead and take a look at our first theorem, which is the side, side, side similarity theorem. So this one states that if the corresponding side lengths of two triangles are proportional, then the triangles are similar. And I'm going to go ahead and walk you through this once you copy down what you need to fill in. All right, so just to show, now let's say we don't have any angle markings and we're really not sure which sides to match. What we're going to do is identify the largest side, the smallest, and then like the middle number, or the medium size. So this is the smallest side of this big triangle. This is like the medium or the middle side, and then this one's the largest side. And then I'm going to do the same thing here. This is the smallest, so like small, medium, and large. This will be the middle one, or the medium. And then this is the largest side of the little triangle. So when I go to set up my proportions, I'm going to put the 6 with the 3. I'm going to simplify the ratio, and it simplifies 2 to 1. Then I'm going to do the same thing with the medium size, or the middle number, 8 to 4. It also simplifies 2 to 1. And then lastly, the largest side and the big one, and the largest side in this little triangle, 10 to 5, 2 to 1. Because each side simplifies to the same ratio, I know that these two triangles are similar, and the reason is the side, side, side similarity theorem. We could have also used, if they provide a similarity statement, you can also look at the order of the letters. So for example, A, B is the first two, and that's why I circled those in blue, and it matches with D, E. And then B, C, the next two, match with the last two here. And then first to last is the green. So always use your similarity statement to see which sides are proportional. Let's see the side angle side similarity theorem. So for this one, it states, if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. So in order for side angle side to work, it must be the included side. The included angle. And in here, the included angle, the angle that's formed by the two proportional sides, they're angles A and D. So I can see that angle A is congruent to angle D. They have the same congruent mark. And then I'm going to match the same thing with my sides. So I can see that AB is the first two. It's going to match with the first two here. So AB is 8, and it's going to match with DE. 8 over 4 simplifies 2 to 1. And then I can do the AC, beginning to end here, 10 to 5. And it also simplifies 2 to 1. So because my two sides are proportional, and it is the included angle between the two proportional sides, I can say that these two triangles are similar using the side angle side similarity theorem. So there's only 3 shortcuts to prove triangles similar, whereas congruence, it had 5 shortcuts. Let's try some examples. So example 1, it's got two parts to it. So it says the measures of the sides of ABC. So I'm going to just draw two triangles. My triangles are not drawn to scale. I'm just going to draw two triangles and label them with ABC and XYZ. So if I draw the first one and call this one A, and let me put A up at the top, A, B, C, and then I'll do this one X, Y, Z. Now obviously I should have probably drawn it a little bit bigger, but again, my figures are not drawn to scale. So I'm going to label the sides. So it says the measure of the sides of ABC are 4, 5, and 7, and XYZ are 16, 20, and 28. Are the triangles similar? So let's go ahead and check it out. Now we do not have a similarity statement, so this is where that small, medium, and large can come in. So I'm going to match the sides based on how big they are. So I'm going to look for the the smallest side of ABC, and I'm going to match it with the smallest side of XYZ. I'm going to put it over 4 over 16. I'm going to reduce that to 1/4. Then I'm going to look for the middle number, which is 5, or the medium-sized number, which is 5 here and 20 here. So 5 over 20, this one also simplifies 1 to 4, or 1/4. And then lastly, my 7 to 28, which also simplifies to 1/4. So because all three sides are proportional and simplify to the same fraction, I could say that yes, triangle ABC is similar to triangle XYZ, and the reason is side, side, side. (2.5). I can't leave a decimal in a fraction, so I can move it once here, move it once here. Essentially what I'm doing is multiplying the numerator and the denominator by 10. I can reduce 20 over 25, divide them both by 5, and it simplifies to 4/5. I now am going to try to match the next side. So I can match BC with YZ. So BC is 6, YZ is 2. So 6 to 2 simplifies 3 to 1. Soon as I see that these two numbers are different, I can stop and say, no, they are not similar. And my reason could be that the sides are not proportional. So sides not proportional, and I know nothing about the angles. So I couldn't even use angle. So no angle information is given, only side lengths. So the only thing that potentially would work would be side, side, side. But as soon as I found two sides that did not simplify to the same ratio, I would stop and say they're not similar. All right, so for example 2, they are giving us that AXYQ is similar to AXZP. So let me trace over AXYQ. AXYQ is this triangle right here. I'm going to pull it out and I'm going to write it over here to the side. And then I'm going to do the AXZP in blue. AXZP is this one right here. Now, based off of my similarity statement, I can see that angle X and angle X are the same. They're in the first spot, so they're congruent. And then I have angle Y is congruent to Z. And then lastly, Q congruent to P. Now, I don't know anything about sides yet, but because I know my triangles are similar, I already know that my sides are going to be proportional. So to help me figure out if AXPQ is similar to AXZY, I'm going to add some numbers here to simplify my process. I'm going to make them so that they're proportional. So I know that side XP, I'm going to give it a 2. XP is the first and the last, and it's going to match with XQ. So I'm going to scale it up by timesing it by 2. And then XZ, which is the first 2, I'm going to give that one a 6. I'm going to scale it up by timesing it by 2. And it's going to match with XY. And then I'm going to give a number to PZ. I'm going to say this one's 8, scale it up, and this one's 16. This is going to help me now, and I'm going to redraw these two in green and yellow. So XPQ is this little one in the top. I can add in the sides. So XP is right here. So it's 2. And XQ is over here. It's 4. Then the next one, XZY, is the whole large triangle. And I'm going to add in their numbers. Let me add in the letters too. X, Y, Z. And I know that XY is 12 and XZ is 6. Now, to show that these two are similar, I already have the angle that they share, which is X. Now I just need to check the proportionality of the sides. So XPQ, let me just rewrite this. So this is my green one. And then I have XZY. Oh, I want to do this one in yellow. All right, so now I'm going to match sides. So the first two sides here, XP is the 2, and I'm going to match it with XZ, which is the 6. Simplifies 1 to 3. Then I'm also going to grab the XQ, first to last, with the first to last here. So 4 over 12. Also simplifies 1 to 3. So my sides are proportional, and I also have that angle X is congruent to angle X. So I could say, yes, they are similar, and my reason is side angle side. All right, ready? Here we go. All right, so here it wants us to name the similar triangles and give the postulate or theorem that justifies your answer. Now, in our book, they're all theorems, so we don't need the word postulate. Some textbooks call angle like a postulate. So every textbook's different. Just know that there's either an angle postulate or theorem. For our purposes, they're all theorems. So let's take a look at the two triangles, and let me pull them apart to show you the two triangles we're referring to. So the two triangles I'm referring to are this little one in the top, ADE, and I've got 80 degrees here. And then I'm also going to compare it to see if it's similar to the ABC triangle. And this angle down here is also 80 degrees. Now, as you can see, when there's a triangle inside a triangle, they're going to share an angle. So this angle A up at the tippy top is the same in both. So because I have two angles that are congruent, the two 80s are congruent, and then angle A is congruent to angle A by reflexive, I could say, yes, these two triangles are similar by angle, and my similarity statement I could write will be ADE is similar to triangle ABC. Again, make sure everything matches. So obviously A and A are the same angle, D and E are both the 80, and then C and E. Let's try to pull apart B. So again, if I talk about the top triangle, CDE, this is 6, this is 10. And then now I'm going to talk about the larger triangle, the ABC. This side of the larger triangle is 6 plus 3, it's 9. And then this side here is 10 plus 5, and it's 15. Notice they both share angle C. And now I just need to make sure that the sides are proportional. So I'm going to match 6 and 9. Simplifies 2 to 3. And then I'll match 10 and 15, and it simplifies 2 to 3. So because the two sides that are forming the congruent angle, the included angle, are proportional, these two triangles are similar by side, angle, side. And again, you could state that angle C is congruent to angle C, and your reason would be reflexive. Let's go ahead and name the similarity statement. So I could say that triangle CDE is similar to triangle CAB. Again, order wouldn't matter, just as long as everything matches. One last example on this slide, and then I'm going to add 2 more examples just to practice this a little bit more. Let's try part C. Again, I'm going to pull them apart. So this little one on the top, that's the KLM. 3, 6, and 5. And now I'm going to draw the larger one, which looks like it's upside down. KNO. 10, 6. To get the length of this side here, I'm going to add 6 plus 6, and it's 12. Now let's match. So now here's where it's going to pay off if I match the smaller number with the smaller number, and then the medium size, and then the larger. So I'm going to match 3 and 6. They're the two smallest numbers. 3 and 6 simplifies 1 to 2. Then I'll match the 5 and the 10. 1 to 2. And then lastly, the 6 and the 12. So 6 to 12, 1 to 2. So yes, these two triangles are similar, and my reason would be side, side, side. we can write a similarity statement. We can say that KLM is similar to triangle. Let's see, we'll go from here. So KL, we're going to go so KO, is that an O? Yeah, KO, KON.
Hey, Corey.
Yes.
Couldn't you also do side angle side for letter C?
Let's see. What's the angle that's congruent?
Angle K.
All right, so angle K is, for this one, it's over here. But for the bigger one, it's over here. So it's not the same angle K. So this one right here, this is going to be angle LKM. And then this one would be angle NKO. They're different.
Okay, thank you.
You're welcome. All right, let me add two more. Question?
Can you see now if I can take a picture, please?
Of the whole thing?
Yeah.
All right, I think that's it there. Oh, wait, let me squeeze a little bit more. There you go.
Okay, thank you.
You're welcome. All right, let me add two more examples just to reinforce this. Let me draw what looks like a bow tie. And I'm going to add numbers. So 5 and 8, 6 and 10. Now, at first glance, you're thinking, oh, maybe this is because I've got the vertical angles. However, let's double check that the sides are proportional. So if I match 5, the smaller number with the smaller number here, it would be 5 to 8. And then if I match the bigger number with the bigger number here, 6 to 10 simplifies 3 to 5. These are not proportional, so this would be not similar. And then let me do one more with the bow tie. And let's say we put 5 and a 10 and a 4 and an 8. So again, I can match the smaller side with the smaller side here, because the two triangles I'm trying to show are similar are this one compared to this one. So if I do 4 to 8, simplifies 1 to 2. If I do 5 to 10, simplifies 1 to 2. Now, I don't know the third side. I do have an angle pair in here that's congruent. I could say that this angle is congruent to this. But remember, it must be the included angle. So this one, the way that I just did it, these are not similar. But if I would have given you that this included angle was congruent, then they would have been similar. So with the included angle, marked as congruent, then they're similar. Okay, they're not similar with just the vertical angles and the proportional sides. Vertical angles in this particular problem is not the included angle. I just wanted to show you a few more examples just to reinforce the topic. Any questions? Anybody need me to go back to any slides?